Hello everyone, and welcome to our webinar on Introduction to IoT Penetration Testing. I'm Nandini Bharadwaj, the Operating Officer at CWL, and I'm excited to have you all here with us today. So let's get started. Okay, so before we start, let me tell you about us. So, CyberWarFare Labs is a leading cybersecurity infosec company offering comprehensive solution to help individual and organization to develop essential cybersecurity skills. So, our offering includes LMS, that is Learning Management System platform. It provides enroll user with course study materials, including HD videos and PDF for a wide range of cybersecurity courses. And the second one is CCSP Labs portal, that is CWL Cybersecurity Playground, where we offer theme based labs designed to simulate real world scenarios. So, user can start the labs at their own convenience, providing flexible hands on practice. And number third is Infinity Learning Platform. So, it is a plug and play platform offering immersive learning experience with challenges across red teaming, blue teaming, and cloud security domains. So, CWL also support customized on-site training requests and accept bulk orders for corporate training needs. So, to get more information or to place an inquiry, contact us at support@cyberwarfare.live. Okay, so let's move to next slide. So let me introduce to our speakers of today's webinar, that is Kushagra Srivastav. Kushak Srivastav is an intern at CW Labs. His research areas include Windows and Linux internal, vulnerable research, fuzzing, and embedded development. He is here to give a talk on Introduction to IoT pen testing. So we are excited to hear his insights today. And that's all about the speaker. And dear participants, as promised, we are excited to share that you will receive your attendance certificate and video recording with the PDF material of the webinar. Along with that, all the participants who are attending this webinar will get a guaranteed access of Infinity Learning platform just after the webinar. So thank you for being part of this engaging session, and we look forward for your continuous participation. And here, without further ado, I would like Kushagra to take over, and let's get started.
Hello everyone, am I audible? Okay, so today's topic is Intro to IoT pen testing, where we will see about how we can getting started with the IoT pen test and include analyzing the firmware. So it will not going to be so much technical, just a brief intro about IoT and embedded devices and basic stuff. So let's continue. So today's agenda is what is IoT devices, IoT hacking, communication and debugging interface, UART, SPI, and then demo. Then we will see the hardware for IoT pen testing, where we will see like devices like Tiger and Bus Pirate. So what is IoT devices? So IoT devices is everywhere right now, from our smart TV to refrigerator, watches, router, fan, light bulb, now toothbrush also, which is kind of funny. So IoT devices are devices which can become smart by connecting to the internet. And as we can see in the last point, these days kid toys also becoming smart, and they are like uh, IoT devices. We have seen like some toys which is like which have camera, or you can record the voice and send it to your phone or something. Okay. So why IoT security? So as we know, everything is vulnerable, which is connected to the internet. So devices which are connected to the internet means devices can be compromised or it can be hacked by hacker. And these devices run various operating systems, makes them susceptible for software vulnerabilities that can be exploited to take over the device. So it doesn't matter if you are in the same connection or different. Yes, someone can compromise your Wi-Fi router or Wi-Fi camera even your fridge, refrigerator, oven, anything. And IoT security is not like traditional IoT security, so IT security, sorry. Um, so hacking IoT requires different skill set and technique. So we cannot just jump to the IoT hacking without doing the basic. So it actually requires different skill set like basic knowledge about currents, electricity, voltage, then the communication protocol, and so on. So it requires some also soldering things where you have to desolder the board, desolder the chip, or attach the pins for debugging purpose or for connecting the serial interface. So let's see how is IoT hacking is different. So IoT hacking, we cannot connect or interact with the IoT devices directly. So it is not like I open up the pursuit and now I can see every request going on, or I open up the IDA, I can completely disassemble the binary or something. So we need actually hardware to connect with the IoT devices. So for example, if I have a Wi-Fi router and I want to test it, test for software vulnerabilities, or I want to see how things are going under the hood. So we cannot just directly interact with it. We need some hardware for for IoT hacking. So we can communicate with IoT devices through interface like UART, SPI, I2C, JTAG, and SWT. So these are the interfaces which embedded devices or IoT devices have to connect with the serial connection. So from these type of interface, we can connect with IoT devices. So communication interface in IoT devices. So embedded device use variety of communication protocol as we saw that. So key protocols. So I will solely focus on the main one, which are the UART, SPI, SWT, I2C, JTAG. So particulars UART and UART and SPI, and these are the communication protocol, and JTAG and SWT are for debugging purpose. So importance, understanding this protocol is probably helpful. So we need to learn about the basic before jumping to the IoT hacking. Accessing communication interface. So as we see in this, as we can see in this particular image, we have these three uh, places for pin, and this is the SOIC chip, right? So uh, these particular interfaces like UART, JTAG, SWT usually don't come with in production unit, and it is disabled by manufacturer, or they just tighten the security so that no one can access it. But still mistakes happen, and vendor actually ship with UART, JTAG enabled, or this kind of particular interface which allow researcher or pen tester to open up the router and start analyzing the board and start connecting with it, which also helpful for development purpose if you are into IT development or embedded development. Yes, it come handy if you see the UART or JTAG. So you can learn how actually these communication interface are working and how you can interact with it. So before accessing communication interface, we have to some know like need some basic electricity knowledge. So we sometimes it's happen if you don't know about voltage and current is you might burn your board. So voltage is electric potential in short, and it refers to the electric potential difference between 2 points indicating how strong electrons are flowing. So the point here is how strong electrons are flowing from one end to another. So this is the voltage. Then we have the current. So and how numbers of electron moving from a certain point in a given amount of time. So this one is for current. a flow of electric charge which is flowing inside a conductor, and resistance, so opposition of flow of the current in a material or in a conductor or any body which can pass the current is known as resistance. So Ohm's law is if you know two things, which is either I or V or I or R, which is current or voltage, you can find the resistance. Or if you know the resistance or voltage, you can find the current. So it is um, so the relation between the voltage, current, and resistance, Ohm's law. So let's move to the communication and debugging interface. So UART is for universal asynchronous receiver transmitter. SPI, then we have I square C and JTAG SWD. So we will see what UART and SPI is, and we will, if we have some time after ending this session, I will talk about I square C, JTAG, and SWD. So what is UART? UART is a receiver and transmitter. Um, it is used for receiving and transmitting the data. Sometimes it's also referred as TTL, which is transistor logic. So UART have three things which have to focus on: receiver, transmitter, and ground. And after that, we will also see how we can find UART on the particular board, which include Wi-Fi router or any Wi-Fi router or camera or any type of embedded devices. So UART usually use voltage of between 0 to 5, and these are the common one. These are the you will find 1.8, 3.3, and 5 voltage, 5.0 voltage. And when no device is transmitting the data, the bus is in idle state. So uh, when there's no communication is going on between your serial device to the router or meter device, then the bus will be in ideal state. So how we can identify the interface? So look for the pin label as TX, RX, or ground. So you can easily find the UART. Even if we don't have ground, we have to only look for TX, RX. Just look for any three dots or three pins where you can find so where you look like UART. So in this particular image, we can see it is TX, this one is RX, this one is ground, and this one have some voltage, 3.3 volt. So one this one is VCC, it is for voltage. So every pin has label, no hardware needed. We just have to solder it through soldering iron, and that's it. Then let's move to the second one. What if we don't have this particular tag, uh, like TX, RX, and ground? Then how we can identify it? So for that we have to use uh, logic analyzer or multimeters. So with the help of multimeter, you have to identify which pin is transmitting the data, which pin is receiving the data. So you will see the noise whenever you turn on the Wi-Fi router. Uh, you have to find the ground, and after finding the ground, you have to use for receiving the data. It will start making noise on multimeter, so you will see the fluctuation. And same for uh, transmitting. Or if you don't want to use multimeter, you can use logic analyzer. So logic analyzer is a device which we can use to uh, see what actually happening under the hood. So with logic analyzer, we can see what actually how data is uh, passing from Wi-Fi from router to my serial adapter. In this case, we have Tiger. So for connecting the UART interface, so we have Tiger and any type of serial adapter. So here, as we can see, we have Tiger. So we don't need all these. We just need one. So Tiger UART to USB. So Tiger is a very good device which allows you to dump the firmware, which it have spy, UART, JTAG, Cortex. So Tiger have every feature, and we have UART, USB bus pilot is also good. Hydra bus is also good. We can give 4 devices if you don't want to spend so much money. Right now, you can go with UART to USB. So it will probably cost around $4 or $5. So this is the board as we saw here, TX RX ground, right? In uh, Tiger, we will also get C connection TX RX ground. So here TX goes with RX, RX with TX. So TX with RX, RX with TX. So it is very simple. So we have to turn on the Wi-Fi router, and TX is for transmission. So if we are transmitting data, so someone has to receive it. So this is why it will goes with RX. And from our USB, from our PC, if we are sending any data or anything, so it is going to receive in the Wi-Fi board or any board embedded device. So ground with ground for completing the connection. So here's the detailed diagram. Both TX connect with RX, Tiger RX, RX with Tiger TX. That's it. And for VCC pin, we already saw this VCC pin, right? So with the help of VCC pin, it can automatically adjust the voltage, whatever voltage board requires. If it is operating on 3.3, so with the help of VCC pin, we don't need to manually set the voltage on the Tiger. So for connecting, after setting up the all the work, we have to uh, get the interface. So we can use the screen command and access the which interface we are want to access. In our case, it is TTY USB 0, and is baud rate. So here's the command breakdown. If you want, you can read it. So bound rate might be differ for different boards. So they are like pretty common, or board which most of the time router or any embedded device, which is 9600, 9600, 19200, 38400, and 15200 pound per second. Then here's the SPI. So SPI is for serial peripheral interface. It is used to control uh, IC sensors like heat sensor or memory devices. So it is synchronous serial communication protocol. So it is based on master slave communication. So uh, it can control many device, many peripheral at once. So even I mentioned it here: sensor, memory devices, and other ICs. Now we will see how SPI looks like and how SPI works. Then we will see how we can find the SPI and connect with the Tiger or any devices which we have. So in SPI, let me see. Okay, so yeah, so this is the pin 1, and here this is the pin 2, pin 3, pin 4. So this is the diagram for understanding. So this particular P1, so it actually activates the SPI chip for communication. Nothing much. This is the job of the pin 1, which is CS. Then we have CIPO pin, which is controller in peripheral out. So it is used for receiving the data and data output from SPI chip to the controller. Then we have WP pin, which is write protect. So write protect, it is used as a safeguard. So it prevents writing into the memory while the SPI is active, or while the any action is going on the SPI. And we have ground. So ground is for completing the connection, completing the electric circuit. Then with pin 5 we have COPI. So it is used for data input from SPI chip from the controller. And then we have serial clock, which is pin 6. So it is used for um, transmitting the data between masters and slave. from it is in simple means transmitting data from masters to the sensors, or if we have ESP8 to ESP board, so we can attach the sensor. So it is used for the transferring the data, transmission of the data. Then we have hold. So actually, what hold work is, it used for halting. So it pauses the communication without resetting the SPI interface. So it is used for halting. It's come very handy if you are working with embedded devices. And VCC, it is for power supplies, and it goes up to 5.5 volt. Let's why SPI in embedded devices. So if we have UART, then why do we need SPI? So UART and JTAG provide direct access to system cell, and we have some issue with this particular UART and JTAG. So cell might be restricted or require auth. So vendors, if they are not stripping out the UART or JTAG, they provide the login for the UART or JTAG. And in case two production unit might lack UART JTAG interface completely stripped off from the board. So how we gonna interact with the board if we don't have UART or JTAG? So this is where SPICE come in, SPI memory come in. So with SPI, we can extract or dump the firmware from SOIC. So dumping the firmware allows analysis of the entire firmware running on the board. So we can actually extract the firmware from the router or from the camera. Then we can manually start analyzing the binary and try to find which can help us to exploit the router or bypass the auth. And the third thing is cracking the hash from etc set of file, which can allow lock-in from the serial connection, which is in our case UART. So we will also see why do we need this SPI. Okay, so why SPI in embedded device hacking? So as I mentioned, we can find the software-based vulnerabilities like buffer overflow, off by one, hard-coded credential, and remote code execution, auth bypass, which allows bypass the authentication of the any embedded device. Either it is hosting a web server, or if we can find ATC password file, then yes, we can pass it through serial connection. So uh, most of the time architecture might different. Yes, you need to learn different type of assembly syntax. You have to learn MIPS assembly. For ARM, you have to learn assembly syntax, and for RISC V, you have to learn different assembly syntax. So system is even for assembly, but you need to learn the and basic stuff for if you are into embedded hacking. So for connecting with Pi, we have USB to serial, which is CS341A. It have 8 or 16 pin. SOIC clip. So this one is SOIC clip. And then we have Tiger. So with Tiger, we can easily connect SOIC clip here in this particular page. But we have to remember that. So if we can see this red wire here, so this will goes with CS. Here's a tag if it is visible to you. So this will goes with CS. Find the SPI. So we have to find the SPI on the board. Flash chip normally have 8 or 16 pins, so it can be either 8 pins or it can be 16 pins. So we have to look for any type of memory which have 8 pins or 16 pins and is the single dot. Look for the small dot here. If as we can see in the image, dot represents CS select pin, chip select, as we already discussed. And then SOIC clip with red wire will connect on the dot side. So particular this is the uh, pin 1, and this particular clip with red side will connect this on this particular dot. So after connecting with SPI, we actually have to dump the firmware for analyzing the binary or analyzing the firmware. So we can use flash room command. So programmer type might be different. So this is the breakdown actually of this command. So Tiger use FT2232 2232 for dumping the for board type, and for bus pirate you will get different you have to actually see the documentation on the Tiger website or on the bus pirate website to get the programmer type. Then we have the port and divisor and particular file name. So it is um, start extracting the firmware from the spy chip SOIC. So after dumping, what we can do? So after dumping, we have to extract the firmware. After extracting the firmware from the router or any type of board, we have to unpack it. After unpacking, we have to find the vulnerabilities or look for any type of hardcode credential or default username password, which can help us to explore the IoT board. So let's see. Uh, so this is the binary which I have. Can I guess you guys can see my screen, right? Terminal. So we are going to extract it. Log. So we can go into the etc folder. Then we have this password file. Let's try to read it, and it's empty. But we also have password dot backup file. So as we can see, we have the admin access. So instead of cracking, so there we have two options right here. So the first thing which we can do is I this we can just simply Google it. The reason why we are Googling it, there might be some person who already did all this research or something or cracked club password. So there is already research is done. As we can see, we have many results. Oh, it's taking some time. Internet issue probably. So here's the after all here's the wrap up for this. Either we can for cracking this password, or we can simply Google it and try to find person who already cracked it or something. So that's level shifter for the voltage. Then we have IRC and we have here UART, and it is for cortex debugging. This is for JTAG, and this one is for spy, as we saw that previous slide. So this is the Hydra bus, and it is for dumping the firmware CS341A. So dumping the firmware or flashing the firmware. So with even with the Tiger, we can also do the same, but it is only its solely purpose is dumping the or extracting the firmware or flashing the firmware. Then we have JTagulator for finding JTag spin, and then we have bus pirate, and we okay. So yeah, we have this. We can particular search for the hash, and we got the result. So this is the particular binary which is already analyzed. Okay, so we actually have some time. So I like to discuss a little bit about this communication and debugging interface. So I will mostly focus on why it is important in IoT pen testing. So for UART, we have serial communication. It is provides serial communication between device, which is from router to your computer or any type of system. So, and the best part about UART, you commonly find in most of the embedded devices. So, and after finding, you can monitor or interact what's going on using the serial console. Then we have SPI, serial peripheral interface. So it is useful for extracting and analyzing the firmware from SPI or SOIC memory chip. So if you don't want to connect with UART, or there's like some particular auth or some login required, you can use SPI to dump the firmware. And the best part about SPI is, uh, let me see. So yeah, so even if your board is broken or something, you can desolder this SPI and connect using test clip or test hook, and without the help of the board, you can extract the whole firmware. And this is where Tiger comes handy. Then we have I2C. So it is two-wire synchronous communication protocol. It is used for interacting with the other peripherals such as sensors, which include like heat sensors or something, and IC, and our board memory. So this is the I2C work. Then we have JTAG. So JTAG is for it is industry standard protocol testing and debugging interface. So it provides low-level access to the internal state of the chip. So yes, it is solely focused on debugging, how we can debug the interface, how we can debug the embedded device. So it is used for boundary scan testing, system programming, and debugging at the hardware level. So you can get a clean, proper overview with the JTAG if you are exploring JTAG section. With SWD, it is a two-wire protocol for debugging ARM-based microcontroller. So, and it is simple and less complicated as compared to JTAG. So, JTAG require so many pin configuration. We have to identify the pins if there is no data set using JTagulator. But with what happens is SWD, we can easily find the pin, and it is not like JTAG. So it is used for accessing the debug interface and performing tasks like memory insertion and firmware update. So this is all for this communication and debugging interface. And let me see. So in this particular demo, let me try to show you one thing. We have been so probably this particular auto, whenever it will get load after like powering on, so it will open up the we can access the GUI using web server or something. So we what we can do is we actually try to analyze this particular these files and try to find the vulnerabilities. So maybe you will find the or bypass or SSRF or this kind of vulnerability, or let me see user local. So it also has some files, and we can actually analyze these files and try to find the vulnerabilities in them. Sorry. We can try and try to find the vulnerabilities in this in this kind of binary, which help us to get the remote code execution, and we can successfully take over the router or any type of embedded device. So let me jump back to the last slide. So closing note. So we learn about basic of electricity, knowledge, some communication and debugging interface like UART, and we saw that how UART, what is UART, what is the work of UART, how we can connect the UART, how we can find the UART if we don't have any type of labels on it. And then we saw that what is SPI, how we can, and what is SPI, what is the role of SPI pins, what each pin's work is, then how we can connect with SPI, then how we can extract the firmware from this SPI. Then last we saw that hardware for embedded pen testing. So If everything goes well, I will probably continue this talk next time, where I will practically show the how we can actually use UART, SPY or JTAG to analyze or interact with the board. And yeah, that's it. Thank you guys for joining the webinar and have a good day. Okay, so yeah, if you guys have any question, you can ask. Let me stop sharing my screen. Okay, yeah, so I will spend like 2 or 3 minutes for questions and anything. And as I promise, if I will continue this talk next time, so I will show you how we can practically connect with this router and all this stuff. Wanted to video from the schedule, that's very quick. So Flipper Zero is a device which is for signal pen testing and something. But yes, even with Flipper Zero, you can with the help of Flipper Zero, you can connect with UART or SPY. As far as I'm guessing, this is what you if it is your question. Yes, you- Okay, so no, actually, yeah. So for Nelson, uh, thank you. And I don't have any idea about right now IoT hacking course, so you guys can mail this question to the office. And what type of OS? Okay, so what type of OS I'm using? So I'm using Fedora, just Fedora. So it just work. Can we emulate the firmware? Okay, yeah. So we can emulate. This is a good question, Abhishek. Yes, we can emulate the firmware using Kimu, and that's the whole part. We can emulate it. We can fuzz it. So fuzzing is different concept in IoT pen testing and or vulnerability research. Yes, we can emulate the whole firmware. How important is student aiming to make a career in cybersecurity to know about IoT and cybersecurity? So here's the thing. This is the like my personal point of view. It is for Bharti, and you don't need so many expensive gadgets or some hardware. So if you are like okay, so if you want to start in IoT or embedded development or programming, you can buy some microcontroller or SPI32. I can share the link if I will get the time. So using this, and you can buy like UART to serial, or even if you want to know about how spy work and dumping the famous. So these type of devices cost under like 10 USD. Okay, let me reread this question. How important is for a student aiming to make a career? So can you? I still didn't get your question. If it possible, as a blue tumor, how we can find a IoT has been compromised? Will there be any locks in IoT devices? Yes, there will be locks. So IoT devices actually store the logs. Also, I don't have UART monitor. No, so yeah, Kali Linux is a but and I just want a bare minimum OS. So yeah. Also being in India, getting IT independent job is harder. How do you suggest this kind of role or position we should look for? Looking for transit from complexity to and invite. So Abhishek Das, this is what I want to tell you. I am intern and my role is as a security researcher where I have to find or my main focus is vulnerability research. So yes, in India, IoT job is hard, but yes, uh, it is not impossible to find the IT job in India. So if you guys don't have any question, I can close this webinar and thank you for joining. Have a good day. and night, whatever it is for you guys.